In this video, we'll explore the coordinate plane distance formula and midpoint formula. Now, the coordinate plane is a two-dimensional plane with an x-axis that runs horizontal and a y-axis which runs vertically. At the center where they intersect is the origin, which we label as O for origin, and it has the ordered pair 0, 0. Additionally, because of the way we intersect, we're left with 4 quadrants. And we go from the top right, and then we go counterclockwise. 1, 2, 3, 4. And generally we talk about the ordered pairs and whether they're positive, what parts are positive and negative, and it has to deal with your x and your y values. Top right, you're always positive. Top left, your x value is negative. Bottom left, everything is negative. And bottom right, the y values are negative. Now, when we talk about trying to plot points, we're going to be using ordered pairs. And it helps us give the specific location on the coordinate plane as to where things exist. If you see it listed, you'll see a point name is going to equal xy. Sometimes you'll see instead of an equal sign, you'll see a colon. But what that's doing is it's just helping us know exactly where on the coordinate plane this point exists. Some specific names you'll see when you do different things in the coordinate plane is that the x value is considered the abyssa and the y value is considered the ordinate. So if you ever see those terms, you know that abyssa is x, ordinate is y. If we need to plot a point, we're going to start at the origin and we're going to move x units to the left or right and y units up or down. So say I want to plot the point -3, 2 and state which quadrant it falls. So that means I would start at the origin. I'd start right here at my origin. I would go 3 units to the left since it's negative. And then I would go 2 units up because it's positive. And right there would be point A. And if I look, this is quadrant 2. Now, the distance formula helps us understand how far apart 2 different points are in the coordinate plane. If we think about that each point has an ordered pair, we can use the formula where it's the square root of the difference of my x values squared plus the difference of my y values squared. And it doesn't matter which point you make the second point and which point you make the first point, because you're going to square that term. So negatives will automatically become positive, so it's not a big deal. Again, distance is a positive measurement. It's always how far apart 2 items are, and that's positive. So say I have these 2 points, one -4 and -3, 2. If I wanted to plot that, I would have here, and typically we'll see a line segment in between those 2 points to help represent that distance. So I can use my distance formula to help me find out how far apart they are. So I'm just going to use B to be my second set and A to be my first set. So -3 minus 1, x2 minus x1, and then 2 minus -4, y2 minus y1. I just got to pay attention to my negatives and make sure I enter them correctly. That's going to give me -4 squared plus 6 squared. -4 squared is 16, 6 squared is 36, and that gives me the square root of 52. Now I need to simplify that, and I can get that down to 4 times 13, and 4 would be 2 squared times 13, so just factoring the number. And now I can actually simplify this by pulling out the 2, so this 2 the square root of 13. Now, where does this formula come from? If we think about what's going on there, and we draw in 2 additional lines, a horizontal and a vertical line coming from A and B, what we see is that we're able to form a right triangle. And what we know is that with a right triangle, if we label the sides A, B, and C, a right triangle allows us to use the Pythagorean theorem. Now, if we make one simple change to the Pythagorean theorem, we could say that the hypotenuse, in other words, side AB, its measure is going to equal to the square root of a squared plus b squared. And if you look, that would be a squared plus b squared. And think about what's going on here. If I think about A being my horizontal distance, and I count 1, 2, 3, 4. So my A would be 4 units. And if I count upwards for my B, following that vertical line, 1, 2, 3, 4, 5, 6. Well, 4 squared plus 6 squared gives me square root of 52, which is 2 to the square root of 13. So the reason we're subtracting the x's is this aspect of we're finding out how far apart horizontally the 2 points are and how far apart vertically the 2 points are. So we are really using the Pythagorean theorem specifically with the ordered pairs that we have. Now last formula is the midpoint formula, and say we use 2 ordered pairs again. We will add the x's and divide by 2 to give us our midpoint average, and we're going to do the same thing with the y's to give us our midpoint y value. And really the midpoint is finding the average between the 2 points. That's the whole point of the midpoint. So say I use that same example, 1, -4, and -3, 2, and I want to figure out where exactly is the midpoint. So I add my x's and divide by 2, and I add my y's and divide by 2. So -2, 2, comma, -2 over 2. That simplifies to -1, comma, -1. So my midpoint is right here. And I can double check this because if I draw in the 2 right triangles, I will see that they're 2 units over, 3 units up, 2 units over, 3 units up. Those 2 triangles should be identical in size for that to be the midpoint.